Welcome back. Today's lesson is on acids and bases. Yes, that's right, acids, the things that James Bond villains use to burn holes through tables. And bases, well, that's not straight from baseball. It's generally just cleaning solutions like bleach and ammonia and other things that make things sparkly. Hooray! So, acids and bases come in three separate varieties. In first year chem, we're going to focus almost completely on Arrhenius acids and bases. That's a somewhat famous dead white guy that discovered that these two things are kind of opposites of each other and they can complement each other to form water. So, using Arrhenius's definition, an acid is anything that is starting with H, that is hydrogen, and also dissolved in water. A base is anything that ends with OH, as in hydroxide ion. So, anything that goes in here, as long as it's dissolved in water, which means it's got the little AQ, that is an Arrhenius acid. Anything that goes here, or fits this style, is an Arrhenius base. Now, you'll notice I put these parentheses around here that may not be seen visually in most story problems or textbooks, but I'm talking about a positive ion here mixes with the negative hydroxide ion, or a negative ion here mixes with the positive hydrogen ion. And then the subscript might be a 1, or it might be something different depending on the crisscross disco dance move. So pay attention to the naming rules, you still have to know them. They stick with us for a long time. Now, if we take any Arrhenius acid and we mix it with an Arrhenius base, then you'll notice that this H and this OH can be put together to form HOH. But we have a better name for that. Let's reorganize, compress, squish things together, and we'll call that HIJKLMNO. Oh, wait, that's H2O. Yeah, it's that corny joke again. That one revisited you too. So, when you mix an acid with a base, you get water. Where do the leftover pieces go? They form a salt. Now, a salt is some sort of positive ion with a negative ion. That's why I put the positive ion here crisscrossed and came over to the left-hand side, because you have to put the positive thing first. So, in other words, one acid plus a base equals water plus a salt, which is going to be a crystal that is dissolved in the water most of the time. Now, over here we have the pH scale. And the pH scale is a measurement for how strong or weak the acids and bases are. So the pH scale is split into two categories, with 7 being absolutely neutral. This is where pure distilled water lives. Under Arrhenius's definition, it is neither an acid nor a base. So anything with a pH greater than 7 fits into the base category. That's the cleaning solutions like bleach. Anything less than 7 down to 0 fits into acids, which could be battery acid from a car, or it could be citric acid from an orange. It could be lots of other things too. But when you take something from the acid category and mix it with a base, you get water and a salt. So the strength of these acids tells how much it's able to either dissolve or clean or steal ions from its surroundings. And the further you get from 7, the stronger it is. It's based off of a logarithmic scale, though. So if you go from 6 down to a 5, it's not like you just got 1 unit stronger, the way a person that is 5 feet tall compared to 6 feet tall is 1 foot taller, or 1 foot shorter. In this case, it's actually a power of 10. So to move from a strength of 6 to a strength of 5, you're actually becoming 10 times more powerful. And then to go from a 5 to a 4, again, it's 10 times more powerful. So in order to do the story problem conversions in this unit, you're going to want to be fairly decent at logarithms and exponents. So you may need to review that in math class if you need to. But not to worry, I'll also tell you all of the correct button presses on the calculator, and that should work out in your favor. So much like before, where we had this analogy of an office building with different offices and different floors and trying to move from one location to another, that was converting units. In acids and bases, we're going to do the very same thing. Often, we're going to already know how many moles of a certain thing we have. Like, for example, hydrogen. We can know with pretty good accuracy how many moles of hydrogen are inside a certain solution. But we don't know what the pH of that solution is. So in order to find it, it's going to involve some dimensional analysis. Hopefully that's not too intimidating by now, but this is going to be how it works. We use the same metaphor as before. We're piggybacking on that idea of the office building. It's just that this time we're going into the basement. And there is only one elevator that goes into the basement of this office building, and that is in the moles office. So you need to get to moles of hydrogen or possibly moles of hydroxide, because those are the two key players for acids and bases. So if we start up here at moles, this is after you've already gone to moles of hydrogen if you're going toward the left, or moles of hydroxide if you're going toward the right. But either way, you have to start with moles. And then we're going to work our way toward finding either the pH or something very closely related called the pOH. But we'll work toward the pH first because that's the more common. You start with moles of hydrogen. And in order to go down this little map, we need to get to the concentration of hydrogen, which is simply moles divided by liters. And that will always give you concentration. In chemistry, we do these square 90-degree brackets around a certain thing, and that says we're dealing with the concentration of that substance, which is always moles of that thing divided by liters of solution. So to go down to the square brackets, simply divide by liters, and you're finished. Now, to go from concentration and get to pH, that's a little bit more complicated. This is where we involve the powers of 10 that I was talking about earlier. So we will need logarithms in order to go down, and we'll need 10 raised to the power of in order to go up. So if you have a concentration, which is almost always a very, very small number, then you'll take this tiny little decimal and you'll type in the negative log of that tiny little number. And when you do that, the result is the pH. And that should be between 0 and 7 if you're dealing with an acid, or it should be between 7 and 14 if you're dealing with a base. If it's anything outside of that region from 0 to 14, you probably did something wrong. Or the sample problem is not a good sample problem, but somehow somebody messed up. So if you already have the pH and you want to go back up toward moles, then we need to reverse every step along the way. So we need to undo taking the negative log. Well, from math class, we learned that that was called the anti-log. Or maybe you didn't call it that, but it's 10 raised to the power of, and then the negative sign here is simply to cancel out the negative sign here. 10 raised to the negative pH will take you up and land at the concentration of hydrogen. Now, in order to go from concentration up to moles, you'll simply multiply by liters, because that's the opposite of dividing by liters. And in this way, you can travel anywhere you want on the left side of this map. Now, if you already have the pH and you want to find something called the pOH, I'm not going to lecture so much on what that thing is, but I'm going to just tell you how to get the right answer on the homework and the test. So I hope that you're curious about what it is, and I hope that you're able to find that out. But for now, if you want the pOH, or anytime that you're moving across this bridge, it's just 14 minus whatever you have. So if you have the pH, take 14 minus it, and you'll get the pOH. If you already have the pOH, 14 minus that thing equals the pH. So 14 minus what you have takes you across the bottom line of this map. And then as you go up the right-hand side, it is exactly the same as the left-hand side. On our way up from pOH, you do 10 to the negative whatever that number was. And that will give you the concentration. From there, you can take the concentration times liters in order to go up toward moles of OH. Now remember, if you're on the right-hand side, then it will always be focusing on hydroxide. If you're on the left-hand side, it will always be focusing on pure hydrogen. Well, not hydrogen gas like H2, but hydrogen ions. So if you're going down, you divide by liters, up you multiply by liters. On this bridge, if you're going down, you take the negative log. If you're going up, you do the anti-log, which is 10 raised to the negative. And you always take whatever you're starting as the input for that particular mathematical idea. So you should be able to traverse anywhere around this circle, except you cannot bridge across that solid line. So if you have the moles of hydrogen starting right here, and you want to get to the moles of hydroxide, you cannot just go straight across. Unfortunately, you have to go all the way around to each individual office in order to get to the number of moles of hydroxide. But you just do the simple steps, and that will take you there. I think it's time for a sample problem.